Hello, Debashish again from Dev's Learning Hub. So today I am going to start a new chapter, Coordinate Geometry, and in this first class of Coordinate Geometry I am going to give you a overall understanding about coordinate geometry, the concept of coordinate geometry, and what is the difference between geometry and coordinate geometry. So to make you understand coordinate geometry, you will learn what is axis and dimension. Number line by this time already you know, while you have done rational numbers and inequation, putting inequation on number line. And next you will understand the axis. What is the axis and what is the relation between dimension and axis. So dimension, number line, axis, this is the first topic I am going to cover. Second, what is coordinates and quadrants and how the coordinates changes based on the quadrant in which quadrant the point lies. So I will explain that. Next is coordinate versus GPS. Whether coordinate or GPS, which one is the relative position, which is the absolute position, right? Next is, as I said, when you will understand all these things, you will understand easily the geometry and coordinate geometry. What is the difference between these two? Okay, so let's start it. Okay, now let's understand what is number line. What you know already, but still just to explain the differences between number line axis, you need to just recapitulate once again. What is number line? Number line is a line where you can plot any real numbers. So the number line, you have 0 in between. The right side of 0, it along the axis, along the number line, it is towards positive direction, and left side of 0, it is the negative direction. Now what is axis? Axis is when two number lines intersect each other. Two number lines intersect each other perpendicularly. Those two are called axes. So let's look into the picture. When you have two number lines intersect each other perpendicularly, this angle is, this is 90 degree. So it intersects perpendicularly, then this one, the number line along the that is horizontally, this is abscissa. This is called abscissa, A abscissa, and along the y-axis, right, that is called ordinate. I'll come to the point where you need number line and where you need axis, and how many axes you need for what kind of object or geometric figure or shape. Okay, that I'll come next. That is based on the dimension. While two number lines intersects each other perpendicularly, then intersection point is called origin. Just you remember these three things now. So where it intersects each other perpendicularly, that is called origin. The horizontally it's called abscissa, and vertically the number line, it is called ordinate. And when two number lines intersect each other, these are called axes, and this is creating four segments: segment 1, segment 2, segment 3, segment 4, and these segments are called quadrants. These segments are called quadrants, Quadrant's, quadrants. So what you understood from this picture, number lines intersect, two number lines intersect each other at origin. Horizontal number line is abscissa, towards positive direction, towards negative direction. Vertical one is called ordinate. It is also towards positive direction on the upward direction from origin, and from downward direction from the origin is called the negative one. So positive ordinate, positive abscissa, negative abscissa, and it is dividing the entire plane into four segments. Each segment is called quadrant. So there are four quadrants. It's dividing the entire plane into four quadrants. Okay. So now let's understand what is dimension. So dimension of an object is the number of parameters or axes required to specify a point or position of a point, to specify the position of a point on or in that object, right? So there are few keywords you need to remember. So parameters and axes, number of parameters or number of axes required to specify the position of a point in that object is called dimension of that object. So what do you mean by parameters? For an object, right, the parameter basically it could be different, multiple parameters, but here just for your understanding with respect to the measurement of an object, right, to measure the size of an object, what we use? We use length, width and height, right? So these are the three parameters we use to measure the size of an object up to a solid object, right? Let's assume this, but look into this particular table. So the first column, it refers the shape of the figures. Second is the number of parameters. Third one is the number of axes and then number of dimensions, right? So let's say there is a point. Does point has any of these three parameters, length, width or height? No. So point doesn't have any parameters. So the number of parameters for point, it is 0. What is the number of, in that case, so what is the number of axes you require? You don't need any axis. You don't need any axis or number line to represent or specify a point on a point, right? If point doesn't have any length, width or breadth, then how can you define the point position of a point on a point? So therefore, number of parameters for point, since it doesn't have length, width or height, 0 parameters. Number of axes required 0. Number of dimension, that is also 0. So for point, the number of dimension is 0. 0 dimensional figure is point. Then it's a straight line. So to define a position on a straight line, what you need? What are the parameters straight line has? Only length, no width or height. Just understand this is a straight line. Or there's a string, there is a string. It doesn't have any width or thickness or height, right? Width or thickness. So therefore it has only length. For that what you need? Only you need the number line, that's X. There is no ordinate, only the number line, right? You need the number line to specify the position. Let's say if this is the string, then where there is a position, it could be at the positive direction on that particular line, it could be in the negative direction on that particular line. So to specify a position on a straight line, you need just one number line because it has only one parameter, length. So number of parameter for straight line, it is 1. Therefore, the number of axes, it is also required only 1. So, to define or to specify the position in a straight line, you need just one axis, or there is only one parameter, length is required. Therefore, the number of dimension, it is also 1. So, what you can see, dimension, it depends how many parameters or how many axes it requires to specify a point on that in that object. So number of parameters or number of axes equal to number of dimension. Here also for straight line, number of parameters 1, that is length L. Number of axes also, it is only number line, that is along the x-axis, right? Along the x-axis, and number of dimension, it is 1. For a plane, right? So for a plane, let's assume, what is plane? Plane, this is a simple paper. Paper has length and width, 2 parameters. So paper has 2 parameters, length and width. So to identify the position of a point on a paper, so how many parameters you have? You have the parameters 2, length and width. Length and width, no height. So therefore, to specify a position in a plane, you need axes, two axes along abscissa, along ordinate. If there is a point, what is the position of a point? It is not only on x-axis, it is at this point where you need to measure on a graph paper. If you have the x-axis and y-axis, so if the point is here, you need to draw a perpendicular on the x-axis and you need to draw a perpendicular on the y-axis. So this point is the position of a point. This position is, let's say, the distance between O to this point. It intersects the perpendicular. If you draw the perpendicular from this point on the abscissa or x-axis, let's say this is point P, and this point where the perpendicular from this point on the ordinate or y-axis, this point is Q, right? So OP, let's say the distance from O to P, OP equals to x1, and OQ, that is the ordinate, that is equals to y1. Therefore, the position of this point is, first you need to mention the abscissa x1 and y1, x1 comma y1. This is the position. This is called coordinate. So for plane, since you have two parameters, length and width, therefore you need two axes to define the position or to specify the position in that plane, and there the number of axes you need, it is 2. What are the number of what are the axes? X and y. X is the abscissa, y is along the x, it is the abscissa, along the y it is y-axis, it is ordinate. Now therefore, since the number of parameters and number of axes, these two are equal, to define or specify the position of a point on a particular object, the number of dimension is also 2. So number of dimension is equal to the number of parameters or the number of axes that those are required to specify the position of a point in that object. Now there is a solid object where you have all three parameters, length, width and height. Let's say a box, any solid object, or let's say a room, very simple example, room. The dimension of a room, can you just specify the dimension of a room? Just forget about this coordinate geometry. Dimension of a room means the measurement of the room across length, width and height. While some painter paints your room, they need length, width and height to measure the area, how much area you need to cover up for painting, and accordingly they give you the estimation. So length, width and height, there are three dimensions of a room, right? Or any solid object. There, why it is three dimensions? Because they have three parameters. What are the three parameters? Length, width and height. And what is the number of axes you need? You need 3 axes along the, if it is a plane, because you have multiple planes. You know, for a solid object, let's say for a room, right? For a room, it has how many planes it has? It has total 6 planes, right? So when the planes, each of the 3 planes intersect each other, so any corner of a room, it has 3 axes along the length, along the width and along the height. So it has 3 axes. So what are the 3 axes? X, Y and Z across abscissa A, along the abscissa X, along the ordinate or width it is Y, along the conventionally, that's how it happens, and along the height it is Z axis. So what is the dimension? 3. So this is the relation between dimension and axis. The number of dimension means the number of parameters or the number of axes you need to specify the position of a point or location of a point in that object. For one dimensional object, you need just number line. For 2 dimensional object, you need axis X and Y. For 3 dimensional object or solid object, you need X, Y, Z, 3 axes along the length, along the height and along the width, right? This is the discussion you need. I want to make you understand what is the concept of coordinate geometry. For that you don't need to understand more than 3 dimension. Up to 3 dimension is good enough if you understand, right? Okay, now let's understand how the coordinates changes over the quadrants. So as I said, what are the quadrants? Quadrants, when you have 2-dimensional picture, right? 2 dimension, that is for a plane actually. So for a plane, 2-dimensional figure, you have x-axis, that is the abscissa, and y-axis, that is the ordinate itself. Then this x-axis and y-axis, which is creating a plane that is called Cartesian plane, right? For a Cartesian plane itself, to define the position of a point, the position could be here, 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 anywhere, right? So the Cartesian plane is divided by the ordinate and abscissa into 4 quadrants. So if you move towards anti-clockwise direction, in that case, from here, the rightmost top one, this is called quadrant 1 or Q1. This is quadrant 1, or in short form I am writing Q1. Second one is quadrant 2 or Q2. Third one is quadrant 3 or Q3. Fourth one is quadrant 4 or Q4. Right? So if you look into this axis, in which direction abscissa is positive and negative, that you can understand, this is the origin. This is the origin, as I explained on the last topic also. So this is the origin. Now what will happen if the position of the point is in the first quadrant? That means along the axis, x-axis, it is positive, along the ordinate, so along the abscissa it is positive, along the ordinate also it is positive. Now just remember this thing, to mention the coordinate of a particular point. What the convention is, first you need to mention the abscissa of the point and then ordinate. So if there is a point P in first quadrant and the coordinate is x1, y1, that means x1 is, you need to draw perpendicular from this point on the x-axis or abscissa, then the distance from ordinate, from the origin, right? Origin is here, so you need to draw then the distance from the origin to the point where the perpendicular intersects the x-axis. Then this distance is x1, that you need to mention first. So the coordinate system, you need to mention first the abscissa, and then what is the ordinate. From P you need to draw perpendicular on the y-axis or parallel to the x-axis, right? And which point it will intersect, the distance on the ordinate from origin to that point, that is y1. So y1 is the distance from origin to the point where the perpendicular from this point intersects at y-axis. This is the ordinate. So first you need to mention the abscissa, second you need to mention the ordinate. That is how you need to mention the coordinate for a particular point. So now what you can see, for if the point lies in the quadrant 1, then both ordinate, abscissa and ordinate are positive, because right side and left side, this is the first quadrant, this is the first quadrant. So in the first quadrant as such, both x and y are positive. In the second quadrant, if the point lies in the second quadrant, so in here itself it is positive, plus, x and y both positive. If the point lies in the second quadrant, then in that case, in the second quadrant, what you can see, the second quadrant is formed by the negative x and positive ordinate, negative abscissa and positive ordinate. That means it is abscissa is negative, ordinate is positive, minus plus. If the point is in the third quadrant, the third quadrant actually the abscissa it is negative, minus, and the ordinate is also minus. And in the fourth quadrant again, the assumption is you are moving towards anti-clockwise direction, and that's how I have marked quadrant 1, 2, 3 and 4. This is the convention you need to remember. So if the position of the point is on the fourth quadrant, in that case the abscissa will be positive plus and the ordinate will be negative plus minus. So first quadrant plus plus, second quadrant you don't need to remember, just understand the concept. Quadrant 1 abscissa positive, ordinate positive. Quadrant 2 abscissa negative, ordinate positive, minus plus. Quadrant 3 third quadrant, abscissa negative, ordinate also negative, minus minus. And the fourth quadrant, abscissa positive and ordinate negative, plus minus. Always abscissa first and ordinate second. So that is what coordinate versus quadrants, right? So if I say, let me give it in a tabular form, and then I will ask you, then I can tell you by just looking into the point's coordinate, you can understand in which quadrant it is actually. So first quadrant, second quadrant, third quadrant and fourth quadrant. In first quadrant, abscissa or x-axis, x coordinate, that is positive, and ordinate, that is also positive. In the second quadrant, abscissa or x coordinate, that is negative, but the ordinate or y-axis, that is positive. In the third quadrant, you have the abscissa or x-axis, that is negative, and also the ordinate or y coordinate, that is also negative. And in the fourth quadrant, the abscissa or x coordinate, that is positive, but the ordinate or the y-axis, y coordinate, that is negative. Now, just the axis picture you need to remember, and you are moving towards anti-clockwise direction. First quadrant, second quadrant, third quadrant, fourth quadrant. Now, if I give you one point, let's say 2, 3. In which quadrant it is? Because x is positive, y is also positive. That means it is in the first quadrant. If I change the sign, let's say -2, -3, both x and y coordinate, these are negative. X coordinate abscissa is negative, and the y coordinate or the y coordinate, that is also negative. Both abscissa and ordinate negative, both minus and minus. That means it is third quadrant. If the position of the point it is 2 and -3, x coordinate is positive, y coordinate is negative, that means it is in the fourth quadrant. And if the position is, let's say, -2 and 3, x coordinate negative, y coordinate is positive, that means negative positive, it is in the second quadrant. So just by looking into the coordinates of a point, if you are asked to find out in which quadrant it is there, so you can easily find out. So that is the relation between the quadrant and coordinates, how the coordinates changes if the point changes its position in the of quadrants, right? Now we are coming to the point. This is very interesting one. Always you don't need to remember this just for your exam. This is for your understanding, which will be very much useful in future also. And this is a basic difference between coordinate versus GPS. GPS, you know, global positioning system. GPS is measured by latitude and longitude. If I say this is the point, this is the latitude and longitude at Earth, that's how the position, if you look into the Google Earth or somewhere, you can find out the even what is the position of your or location, absolute location of your building. So latitude, longitude, that is measured. GPS and coordinate, that is relative position. That means if you change the axis, because the position of a point, that is based on the position of the origin. That means if you change the position of the axis, which in turn refers to the position of changes of the position of the origin, then your coordinate will also be changed. So coordinate is a relative position of a point which depends on the position of the origin or the axis. Whereas GPS or global positioning system, this is actually an absolute position which is dependent on the center of Earth, which is fixed. Because that center or origin you cannot change, there is no chance of change for that particular origin. So if the origin is fixed, then your position is fixed, that is an absolute position. But the coordinate is the relative position. Now you understand here. Let's say this is a paper or two-dimensional figure, right? Length and width, only two parameters or two dimension, right? And there is a point. This is a point. I want to understand what is the coordinate of this point. So how will I identify the coordinate of the point? First you need to define the axis. So therefore you need to define the origin. So let's say I am defining the axis here. Okay, one thing I didn't say while I explain coordinates, where the two number lines intersects each other, x-axis and y-axis intersects each other, what I said, that intersection point is called origin. And the coordinate of origin, here y-axis starts and x-axis also starts. So origin, coordinates of origin, that is always 0, 0. Now, if I consider this is a graph paper, you plot the point on a graph paper, and that is how the x-axis and y-axis looks like. And all the units have similar distance, same distance, same measurement, both along x-axis and y-axis. Now, what is the coordinate of this point P here? 1, 2, 3, 4, 5, 6. I am assuming all these are 1 unit. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So, if I draw a perpendicular line from P, let's say it intersects here at point 6 on the abscissa, right? And from here you draw the perpendicular on the y-axis. Assume this is at this point, right? So this is, how many units are there? How many? 1, 2, 3. So this is 3. So that means x is 6, y is 3. But what will be the sign? Now you see the length is 6 from origin for abscissa, and for ordinate the length is 3 units. But what will be the sign to give the position of that particular point? For that you need to first see in which quadrant it is. It is in the first quadrant, right? So this point is positive 6, this point is positive 3. So that means it is 6, 3. If the point will be in here for the same location, but in this this fourth quadrant where the abscissa is 6 and the ordinate is also 3, the distance wise 3 units ordinate and 6 units abscissa, but the coordinate will be 6 minus 3 because it is coming in the ordinate, it is coming along the negative direction. So it is minus 3 because this side it is minus 1. So minus 1, minus 2, minus 3. So it is 6 minus 3, right? Now, if I change for the same position, the position remains same. Now if I change the axis, okay. Now if I move the y-axis 2 units right from the current origin, that means the new origin will come at this position. So this will be 0, 0. Now with the revised scenario, this will be the origin. So now if you move 2 units at the right side, that means this distance, this point will be 6 minus 2. this point will be 6 minus 2, that is 4. So, but your y ordinate, that doesn't change. So in that case, what will be the coordinate for this particular point? It will be 4, 3. So even though the position, actual position of the point doesn't get changed, but the coordinate of the position is getting changed because of the movement of the origin. Even the y-axis doesn't change, since only the ordinate doesn't get changed, but because only the y-axis has been moved towards right side. Now even it may happen both the x-axis and y-axis is changing their position, right? In that case, both axis and origin may get changed. So therefore, the coordinate of a particular point, that is relative position with respect to the origin or axis, whereas GPS is that is the global positioning system, that is an absolute position, because that is a unique position with respect to Earth's origin or center. That cannot be changed, right? So coordinates are relative to axis and origin, position of axis and origin, but GPS is an absolute position where it is defined by latitude and longitude, and it is defined with respect to the position of the center of Earth. That is the origin considered. So that is not changeable, right? So if the origin is not changing, then the position is absolute. Since in coordinate the origin may change, therefore it's a relative position with respect to the origin, right? So next is, what is the difference between geometry and coordinate geometry? Now just it's a very simple one. What is the difference between geometry and coordinate geometry? Now while I explained all the above three topics, you understood what is you have understood, I believe, what is coordinates and what is the need of coordinate, right? And what is dimension, number line, axis, all these three, right? Now what is the difference between geometry and coordinate geometry? So geometry, the focus of geometry actually, that deals, the objective of geometry, that deals with the fundamental properties of different geometric shapes and the relationships between them. What does it mean? Fundamental properties. Let's say you are saying in geometry, you are saying that you need minimum 2 points to draw a segment of a straight line. It is a fundamental property to draw a straight line. That is geometry. With respect to loci or locus, right? The point is moving in such a way that its distance from a fixed point, that is center, is always equidistant. Everywhere these distances are equal. That means the point P, this is a moving point, the locus of the point or the loci of the point, that is circle. That is circle. So this is what also another fundamental properties of the relationship, right? So point and straight line, the relationship, you need minimum 2 points to draw the segment of a straight line. This is the loci, right? If two straight lines intersect each other, then the intersection angle, opposite intersection angles are equal. These are geometrical properties. You don't need any algebra. But in coordinate geometry, you need to express any geometric figure in an algebraic expression. Let's say a straight line. If I say y equals to mx plus c, you can see this is an equation. This is an algebraic equation where x and y, these two are coordinates of the points. So if this is an axis, I will explain in a separate chapter also, it is what is y equals to mx plus c and what is the meaning of m. So if this is a coordinate, this is y dot, this is x and this is x dot, and this is the line. Any straight line, if it is not parallel to x-axis or parallel to y-axis, obviously it will intersect x-axis and y-axis both. right? It may intersect at the positive quadrant, first quadrant, second quadrant, third quadrant, wherever it is so, but it will intersect x-axis and y-axis. It may be in the negative direction or positive direction, it doesn't matter. So if this is what the straight line, let's say this is a straight line AB, then we can represent this straight line in the form of y equals to mx plus c, where this c is the intercept, where it actually from the origin, the distance from the origin to the point where the straight line intersects the y-axis, this distance is called c, or it is called intercept, and in which angle actually it is aligned with the x-axis, that is called m theta. Then m, that is the slope, m, that is called slope, that is equals to tan theta, right? So m is the slope, and x and y, these are the coordinates of the point, right? So it could be x1 y1, it could be x2 y2, and you need minimum 2 lines. So basically this is a linear equation, y equals to mx plus c. If I represent a equation in this form, that means it's a straight line, two-dimensional figure, x and y. If I have another algebraic equation, x square plus y square equals to a square, this is an equation of a circle. So that means you are representing a geometric shape with respect to the coordinates through an algebraic expression. That is called the coordinate geometry. So there is no algebraic expression that is required for geometry, but for coordinate geometry you need the coordinates and the algebraic equation to represent the shape of a geometric figure. So that is the basic difference between geometry and coordinate geometry. Using coordinate geometry, you can find out distance between 2 points if the coordinates of the points are given. You can find out in which proportion 2 lines, if the equation of the lines are given, then in which proportion the line it has intersects each other. So lot of things you can do using coordinate geometry, since the algebraic expression it is there. Right. So these are the basic differences. So I hope you have liked this entire video to understand, and it is very much clear to you now about the concept of coordinate geometry and why it is needed, and whether it's a relative position or absolute position. What is the relationship between dimension versus the coordinate, right? Axis. So how many axes based on the number of dimension that object has, right? So if you like this video, please click on the like button, and if you would like to have such kind of video again and again, please click on the subscribe button. Thank you very much.